Hello, everybody, and thank you for coming back to Math 100. Today, we are going to cover the last section, last required section of this course, which is section 8.3. And we are going to talk about voting, election, right? And typically, you may think of just one way to choose the winner of an election based on, who gets the most number of votes. But it turns out there are different ways to declare the winner. And so we're going to learn like 4 or 5 different ways. And this is not just applicable in politics because, we get to choose things like maybe a large number of people will choose where to go on vacation or what game to play or what movie to watch, right? So the theory of election or theory of voting is not necessarily about politics, okay? So let's learn about elections and who wins an election in section 8.3. Let's get started. So section 8.3 is about the theory of voting and election. Okay, and the main question or main questions here, basically, I'm going to ask this one question: what is the fairest way to choose the winner in an election? Okay, because we're going to talk about at least 4, maybe a couple more different types or different methods of choosing the winner in an election. All right, the first one we will study is the most commonly practiced one in the United States, okay, and in other places. But other methods are also gaining popularity in these days. So we are going to learn about these things as well. Okay, now one of the main objectives of a course like liberal arts mathematics is to become a critically thinking, okay, problem-solving citizen, somebody who is literate in numerical or quantitative ways, right? So this kind of thing is very important, right? Because in a democratic world or in a democratic society, elections, votes, okay, that is like extremely important, right? And so I hope you learn these different methods practiced all over the world, and I want you to have some understanding of how the winner is chosen in an election. All right, so let's pay close attention as we study this very last section of chapter 8. Okay, so first I'm going to give you a little a thing here. Who wins an election for a political office, or like in the world of sports, they choose the most valuable player. If you're involved in Hall of Fame election in the sport or a music or something, you cast your vote, right? How do you choose the favorite restaurant? Newspapers run these things like, the #1 restaurant in Los Angeles or something. What happens if you vote for a policy, or if you decide what kind of academic calendar you want for a college, right? So there are many ways or situations in which we have an election. And we basically want to talk about this ranking table first, because this has a lot more information than just casting the ballot for one person. And so we will look at this first, right? The ranking table below. And that's going to illustrate this. Now, let me just explain something else here too. In most US elections, we don't use this kind of thing. We don't use preference schedules. One preference schedule is seen right here. Okay, but we'll talk about this. But we don't use this kind of charts. Okay, we cast our ballots for only one person, right? One person, one candidate. So what you see here maybe looks slightly strange, okay? But let me explain what this preference schedule is first. All right, so let me first explain what this chart is showing, okay? Preference schedule. So you assume we have 5 candidates, all right? And the candidates are named A, B, C, D, and E. All right, and so we, instead of asking people to just pick their favorite candidate, what we do is to ask all the voters to rank these candidates A, B, C, D, E in first place, second place, third, fourth, and fifth place, right? And as a result, it appears that 18 people have chosen the order of A, D, E, C, B. Okay, do you understand what's going on? So these 18 people chose A to be their first candidate. But in case A doesn't win, they want D to be their second favorite candidate, and E is their third favorite candidate, and so on. Okay, now how many ways can you rank these people? So theoretically, there are, this is a permutations problem, right? So theoretically, you have 5 to choose the first place winner from, and then 4 for your second place, and 3 for your third, and so on. This is 5 factorial, which turns out to be 120 different ways of ranking 5 candidates. Okay, that's a lot of different ways. What you see here is that 1, 2, 3, 4, 5, 6. We have only 6 of the 120 permutations represented, but that's okay because people. I mean, this is not just a random schedule. This is a preference schedule. So 18 people preferred the candidates in this order: A, D, E, C, B. 12 people ranked them in the order B, E, C, D, C, A, and so on. Okay, so if you add up all of these numbers on the top row, it'll tell you how many people voted, right? So that's 18 plus 12 plus 10 plus 9 plus 4 plus 2. Okay, and that turns out to be not 120. That's the number of permutations or rankings. You have 55 people voting in this election. Okay, so that part is not difficult. And by the way, we will talk about the majority. You know what the majority is? When 55 people vote, what is a majority? A majority is any whole number bigger than half, right? So if you divide this number by 2, okay, you get 27.5. Well, 27.5 is not a majority. You have to have at least that number, but it has to be a whole number or an integer. So 28 would be the majority or a majority. Okay, so if you have a 28 votes for a candidate, that candidate will have or would have a majority. That's the language we would use. Okay, and by the way, this number is important, okay, because that requires, this is this is more than half, right? Okay, so what do you notice about A? Look at the candidate A. What kind of a person is this, do you think? Well, A is the first ranked choice by 18 people and very, very bottom choice for everybody else. Okay, so A, you can imagine, is, let's say, 18 people like A, maybe worship A, but everybody else can't stand him, right? Or her or him, whatever. Okay, so everyone else does not like A at all. Okay, and they put A in the very bottom. Okay, so who wins if all the voters just cast their ballot for one candidate, right? Remember, that's what we do in the United States in most of the elections, not all. And more recently, you have many states using other methods as the ones that we will see later. But if all the candidates just simply write one name, the name of their first candidate, who is going to win? Okay, and that method is called the plurality method. All right, so let's think about who is going to win. Now, how many people would cast the ballot for A? Well, A is going to have 18 people, right? Now, B, his or her name will appear in, basically you're counting, okay, how many people would vote B to be their best candidate, right? So at this point, okay, in this question, under plurality method, these rows really don't matter. The only thing that matters is the first row, okay? Because everybody is going to write just one name, and that name will be their first ranked candidate, right? So 18 people will choose A, 12 people will choose B, C is with 10 people, right? That's this. And then D will be written by 9 people, voted in by 9 people. And then E, now watch carefully here, because E spans 2 columns, right? So these 4 people choose E to be the first candidate, and these 2 additional people will also choose E to be their first candidate. Everything else here is different. Okay, so for D, 9, and then for E, you have to add 4 and 2, and that's 6. Of course, that's much fewer than others. All right, so it looks like if everybody wrote one name, as we do in many of the elections in the United States, it appears that A is going to win, and that is the plurality winner. Okay, so in this is our method number 1, which is the most frequently used practice or the method in the US. The candidate with the most number of first place votes wins. Okay, so if you decided that the candidate with the most number of first place votes wins, that method is called the plurality method, the most commonly used practice method in the US. Warning, make sure you add columns if necessary, right? So if A appears as the first place candidate in 2 columns or 3 columns, you have to add up those columns, the numbers in those columns, okay? So just make sure you understand that. All right, so the conclusion here is A wins by plurality. No problem here, right? This is the easiest one for us because this is the most commonly practiced method. All right, so now we're going to start asking a couple of other questions here. Look, how many people, if you compare E and A, how many people prefer E over A? All right, now I have sort of made this chart messy, so let me erase some of my marks here. Okay, now how would you figure out how many people prefer E over A? What we want to look at is to see which order do they come in. For these 18 people, it's A over E, right? For these 12 people, E is over A. And in fact, if you just highlight E and A, remember A is last ranked by most people, right? So in all columns except for the first column, everybody else seems to prefer E over A, right? So 18 people would prefer A over E, but everybody else, that's 12 plus 10 plus 9 plus 4 plus 2. Okay, and that's 37 people. 37 people prefer E over A. So E wins. So E wins over A, and the score is 37 to 18. These 18 people would prefer A over E, but the rest of the people, 37 people, like E over A. So E wins over A by the score, and quote unquote score 37 by 18. Okay. Now this kind of a comparison is called a pairwise comparison or one-on-one comparison. You're basically picking one and picking another candidate and see how many people prefer one over the other. Okay, how about E and B? Okay, so this time I'm going to erase all my markings on A, and now I'm going to see who wins between E and B. This is another pairwise comparison, E and B. So highlighting B here and E. Okay, so it looks like, let's see, this is a little more complicated, right? E is preferred over B by 18, right? This, and then see, I'm choosing all the columns where E is above B. See that? And then 9. And then EB, so 4, and then EB, that's 2. And this looks like 37 people again. Is that right? No, that's 33 people, I believe. 27 plus 6. Okay, so that's 33. So maybe I need to write down. So E over A, and the quote unquote score was 37 by 18, right? And then E seems to win over B because the answer is 33. Remember, 33 is a majority. Okay, so 33 and 55 minus 33 is 22. So 22 people would prefer B over E. But in the pairwise comparison between B and E wins because E has 33 people and B is 22 people, right? Again, all I'm doing is comparing E and B, right, in the pairwise or one-on-one comparison. Okay, how about E over C? This time I'm going to erase all my circles for B. And now I'm going to compare E with C. Oh, okay. And so what's going to happen here? E over C, and C is here, 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 C is here. Okay, if you look at these columns here, E is preferred over C by these 18 people and the 12 people next to it. For this one, C is ahead of E, right? Because these 10 people prefer C over everybody else. CE, CE. But again, the 4 people and 2 people in the end prefer E over C, E over C. Okay, so let's add up all of these people. And this becomes, looks like I have 36 people. This is 30 plus 6, 36. So E seems to win over C as well. And this time by the quote unquote score of 36 to what? 55 minus 36 is 19, right? So that seems to be the situation. And how about over D? Okay, so now I'm going to pick just E and D. Let me circle these ones. Okay, I had lots of messy things, so I just erased my markings again. E over D. So here you have D and E, right? E over D. E over D. D over E. E over D, E over D. Okay, so I have 4 columns where E beats D in the pairwise comparison. So this number here is 12 plus 10 plus 4 plus 2. That's 22 and 28. So it looks like E wins over D as well, this time by the quote unquote score of 28. If 28 people prefer E over D, then the other 27 people must prefer D over E. But 28 is a majority, right? So by a majority in the pairwise comparison between E and D, E seems to win. Okay, so did you see what's happening here? I hope you do. So what's happening here? E is actually preferred to everybody else in this whole thing, right? So E is like the preferred candidate of everybody. Even though A was the plurality winner, A was not popular among most of the people. If you do pairwise comparison, E beats everybody else. Okay, so when you want to declare winner, the E as the winner, because in the pairwise comparison, E is preferred over any other candidates. Okay, that method is called the Condorcet method or pairwise method. So if one candidate is preferred over each of the other candidates, right? So if one candidate is preferred over each of the other candidates in one-on-one comparison or one-to-one comparison or pairwise comparison, then that candidate wins. If you apply this rule, that method is called the Condorcet method. Don't pronounce the last T. Condorcet is French, and the last T in the French name is often not pronounced, right? Like many other French names. And so that person who is preferred over everybody else is called the Condorcet winner. Now, it doesn't always happen, okay? The Condorcet winner may not exist in many cases, but in this particular case, E is clearly favored over everybody else, all other 4 candidates, A, B, C, and D. So we declare E to be the Condorcet winner, and E is the winner of this election by the Condorcet method. Okay, now here's another smaller version of, well, it's a different election altogether, but look at what happens here. You only have 3 candidates. If you compare A and B, A is preferred over B in these 2 columns. Oh, by the way, here you have 14 plus 12 plus 10, that's 26, 36 people are voting in this different election, right? 36 people. So A is preferred over B in these 2 columns. That's 14 plus 12, that's 24. Okay, so A is over B by the score of 24 to 12. Remember, these 2 numbers have to add up to 36, right? Comparing A with C, look at the columns where A is over C. That's this one here, and that's CA, CA. So A has only 14. And so let's see, you have 36 minus 14 is 22. So C wins over A. Do you see that? C is over A, or preferred over A, by these 2 columns, right? That's 22 people. So C wins over A by the score of 22 to 14. If you compare the third pair, which is B and C, I'm trying to erase these markings here. All right, so which columns has, let's say, B over C? B over C here, and B over C. So 14 plus 10, that's 24 people. Seem to prefer B to C. The other 12 prefer C to B. So B wins. B wins over C with a score of 24 to 12. All right, so what's happening here? A wins over B, and B wins over C, but C wins over A, right? And so you have this sort of a circular ordering. So nobody wins. I mean, this is just like when you play, rock, paper, and scissors, and there's no winner. And so this could happen in an election. Right? And that is a big flaw of the Condorcet method. If you use the Condorcet method by itself, you may not have a winner, okay, because nobody is a Condorcet winner. That is a problem, of course. So you can see immediately that the Condorcet method has this big flaw, right? Is the plurality method better? Well, according to the plurality method, you have chosen A, which is the person who is hated by everybody else except those people who sort of seem to worship this candidate. So that is a problem too. So far, we have seen sort of 2 methods that don't seem to be very good. Okay, now we have a few more methods to go into, but the instant runoff will take some time. So let's stop this portion of the video at this point. When we go into part 2, we will go into the third method called IRV, the instant runoff vote.